Hello, bonjour, it's Laura here. In this video, I'm going to show you how to solve a typical gas problem. So, I've got a question written at the top here. It says, a heliox breathing mixture of oxygen and helium is prepared for a scuba diver who is going to descend 200 feet below the ocean surface. At that depth, the diver breathes a gas mixture that has a total pressure of 7 atmospheres. If the partial pressure of the oxygen in the tank at that depth is 1,140 millimeters of mercury, what is the partial pressure in atmospheres of the helium in the breathing mixture? All right, so this question is fairly wordy. When you read it, it might not jump out at you the type of question this is and what gas law we should use. So let's go through and underline any of the numbers and units. Maybe that'll help us. So we've got this breathing mixture, we've got oxygen and helium. It's prepared for a scuba diver who's going to go down 200 feet below the ocean. At that depth, the diver breathes a gas mixture that has a total pressure, okay, so total pressure is interesting, of 7 atmospheres. We've got a partial pressure of oxygen in the tank, and that is 1,140 millimeters of mercury. What is the partial pressure in atmosphere of the helium? All right, so let's look first at the 200 feet. Do we know any gas law equations for feet? No, we actually don't. It's just some extra information, so we don't have to worry about the feet. At that depth, we've got a total pressure. So we're dealing with a total pressure here and partial pressure. We don't have any other information. We don't have information about temperature or volume or moles. We're just dealing with pressure in a tank. And there's not going to be moles to deal with either here. So we're dealing with only pressure, and that is going to give us, that's going to be Dalton's law of partial pressure. And the law of the partial pressure says that the total pressure, so the pressure total, is equal to the partial pressures. So the gases that we've got here are oxygen, so the partial pressure of the oxygen, and then we've also got helium. So the partial pressure of these two gases will add up to the total pressure. And we have total pressure. I'm going to sub that in. We've got a total pressure of 7 atmospheres. We've got a partial pressure of the oxygen, and that is 1,140, but it's not in atmospheres. So let's convert that to atmospheres because we want all of our units to match. So if I multiply that by a conversion factor, it's going to be 1 atmosphere equals 760 of the millimeters of mercury. So those millimeters of mercury will cancel out, and then I'm left with 1.50 atmospheres for my oxygen. So that would be right here. And then I need to solve for my pressure of helium. So the way I can do that is I want to isolate the pressure of the helium. So I'll subtract the 1.5 atmospheres. So pressure of the helium is going to be 7.0 atmospheres subtract 1.50 atmospheres. Let me just scroll down. Now when you do that calculation, you should get 5.50 atmospheres. So the pressure of the helium, or the partial pressure of the helium, is going to be 5.50 atmospheres. So that's how you solve a Dalton's partial pressure, or law of partial pressure question. So well done, Miigwech.